Okay, we're looking at lesson 4-2, patterns in linear functions. And it says that we are going to identify and represent patterns and describe linear functions. And as you all know, we see this word line. So that means that the shape of our function will be a line. So we are going to be working with dependent variables. And we're going to be working with independent variable. Dependent variable depends on another variable. Independent variables stand alone. And independent variables are called input values, and dependent variables are called output values, which makes sense because independent, I am putting it in something, and what it comes out, because it depends on the independent, is my output. All right, let's take a look at problem number 1. It says representing a geometric relationship. In the diagram below, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using the table, words, an equation, and a graph. So there's 4 different ways. We need a table, we need words, we need an equation, and a graph. And so here, let's look at it. We have one rectangle, and the perimeter would be, we have this 6 plus 6 plus 1 plus 1. So that's 6 plus 6 is 12. Plus 12. Plus 1 and 1 is 2, so that's 14. And then we have 2 rectangles, so I have that 6 plus 6. And this time, instead of adding 2, I'm going to be adding 4. And then so on and so forth. So step 1, make a table. Use x as the independent variable and y as the dependent variable. So let's name our variables. It says let x be the number of rectangles. So that's independent. And let y be the perimeter of the figure, because the number of rectangles depends, the perimeter depends on the number of rectangles. So write each pair of input-output values x, y as order pairs. So when we have one rectangle, our perimeter, like we said before, is 14. And I even broke it down even more. So we know that 2 times this 1 and 1 is the perimeter of the first one, plus 2 times 6. And then this time it'll be 2 times 2. So we have 2 here, and it's times 2. Next it'll be 2 times 3, and then 2 times 4, and so on and so forth. And so we see that 2 times 1 is 2 times 6. 2 times 2 plus 2 times 6 is 16. 2 times 3 plus 2 times 6 is 18. And 2 times 4 plus 2 times 6 is 12. And then we write it as an order pair. So we have 1 and 14, 2 and 16, 3 and 18, and 4 and 20. So we're going to look for a pattern, and we'll look. This is the words that they use. It says multiply the number of rectangles in each figure by 2 to get the total length of the top and bottom sides of the combined figures. Then add 2 times 6 or 12 to the total length of the right and left side, of the left and right sides of the combined figures to get the entire perimeter. So that makes sense. The equation is 2x plus 12, and that makes sense. Each time we have this plus 12, and then we have 2, and then our x is that variable that changes. So we have that input variable. So 2x plus 12. Then we can graph it. We can just graph those points that were given. Okay, let's go on to got it, number 1. So it says in the diagram below, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. So here I have one triangle, and I want to find my perimeter. So that's 3 plus 3 plus 4, which is 6 plus 4, which is 10. Triangle 2, I have the same 3 plus 3, and then this time I have 2 4s. The next one I have 3 plus 3, and then 3 4s. And then for the fourth one I have 3 plus 3 and 4 4s. So let's put it in the table. Okay, so we have, let's say x is our independent variable, and that's our number of triangles. And then y, we'll say, is our perimeter, and that's our dependent variable. And so I'm going to make my chart. So I have x, and I have y. So for 1, 2, 3, and 4, that's what I have, 4 triangles. For the first one, it was 4. There was 1 4, and then I had 2 3s. and I got a total of 10. For the second one, I had 2 4s, and I still had 2 3s for a total of 14. For the third one, I had 3 4s and still 2 3s for a total of 18. And for the fourth one, I had 4 4s plus 2 3s, or 2 sides that are equal to 3. I'm sorry for not being exact, for a total of 22. And so my XY coordinates will look like 1, 10, 2, 14, 3, 18, and 4, 22. I think the equation is pretty easy to see. I can see that each time I have 6, so that is my my constant value, right? Or even my y-intercept. We can think of it that way. And then here's the part that changes. Here, 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 and here. So 4x. So there's my equation. By words, I'm just going to say it instead of writing it down. My words, I'm going to say that I'm going to multiply the number of triangles by 4. So every time my number of triangles are being multiplied by 4. And then I'm going to add 6. So if we go back and look at that example, I am multiplying the number of triangles by 4, and my 2 sides that are equal to 3. So that's 2 times 3, or I can say multiply by 2, or add 2 plus 2 times 3, or 6. It's the same thing. And again, I'm multiplying my number of triangles by my side 4. That lets me know my bottom sides for my triangle. Okay, and then last but not least, they want me to graph it. So again, I have my x values are here, 1, 2, 3, 4. And then my y values, I'm going to say, let's do it by 5, 10, 15, 20. So my first one is at 110, so 110 is about right here. The next one is at 214, so that's right below my 15, which is about right there. 318, which is below 20. And then 422, which is above. And as you can see, it has that line shape because it's a linear function. I hope this helps.